Are you looking the online platform that can teach you the beauty of advanced physics? Have you ever think about how you can understand, master, enjoy the beauty of advanced physics? Those are some of the questions that I know actually being asked by the advanced secondary students in Tanzania and even in African continents and worldwide. So I don't know about your answer for those questions and even for the other questions. But one thing which I want to tell you in advance, whether it's your first time or second time or third times to meet with me, I would like to tell you that you might get the right answer of that questions, that you have some problems in advanced physics, so you have been looking a place that can help you. My name is Olenjolai Moko Tayai Losingo. Simply just you can call me Olenjolai. I thank God by His own grace who has given me a gift of teaching. So I'll be a teacher who is going to teach you advanced physics. Again, I thank God by His own grace who have created a true love of science. So I really love science since I met it and even to these times, and I don't think if I will never I will retire on loving science. So I will be standing on the positions of a physicist, but not a professional physicist, just a physicist who can teach you what I know. But I want to warn you, remember that Olenjolai does not know everything about advanced physics. I just know small portions of it, but I have an assignment to teach others. So if that's the case, you can be asking yourself so many questions. What have we prepared today for you? What are we doing? How can we help you? So I know you have a number of questions, whether you're a parent or you're a student, you have a number of questions. I would like to take this opportunity to welcome all the national and international students who would like to enjoy the beauty of advanced physics. Again, I would like to welcome all the guardians, parents, sponsors, leaders, and even every kinds of the parents, even those parents who don't have advanced students at this time. But according to the developments of education in Tanzania, I believe there is a time whereby in every family there is advanced secondary students who is pursuing science and mathematics. All right. So that's the point that I want to make. But before even I welcome you on and explain it to you briefly about what I've written on the blackboard, I would like to just to tell you the vision that we have in Tanzania Online Advanced Secondary School in square bracket Olenjolai. The word of God says that in the book of Proverbs chapter 29 verse 18, where there is no vision, people perish. So if you don't have visions in this purpose that you are doing with this business that you are doing, we can perish out. And I'm not ready myself to perish. I believe even yourself who is watching this program, you are not ready to perish. So this is the vision that has been written or been revealed in my heart. I have an assignment to teach and train advanced secondary students on how they can extract knowledge, understanding, and wisdom from the classroom instructions in advanced physics, advanced chemistry, advanced mathematics, and basic applied mathematics, and combine it with knowledge, understanding, and wisdom that I'm going to teach them to extract it from the Word of God in order to solve real-life problems. Also, passing an exams is just a specific objective, but it's not the main objective. The main objective of TOASO is to teach our students to think it differently, and especially to know they have an assignment to answer particular questions or to solve a real-life problems. I know that in the classroom questions, most of them are not testing us to solve real-life problems, but that's an assignment, and that's the meaning of education. So, right now, I believe that you have got this brief information, which is very important. I would like to take you to navigate onto what I've written on the blackboard. There's some writings there, but just spend with just a minute to navigate with you because it's very important. Then we'll get inside the session 60 because I'm very happy today to teach session 60. Firstly, I would like to welcome you into our Tanzania Online Advanced Secondary School in square bracket Olenjolai. Simultaneously, because I'm teaching advanced mathematics, I would like to welcome you into one of our official YouTube channel that's called Tanzania Online A-Level Secondary School in square bracket Olenjolai. So remember that the vision that we have so many specific objectives. We have the main objective for this program. We have so many departments in our online school. One of the departments is called Advanced Physics, and the subject of the day is Advanced Physics for the Form 6, because we are teaching Advanced Physics Form 5 and Advanced Physics for the Form 6. Then we have we have 5 main topics in advanced physics for the Form 6 here, called the Syllabus of the United Republic of Tanzania. And one of them, which is chapter 2, is called the current electricity. So I would like to welcome you in regardless of your faith, regardless of your religions, we are praying to the Most High God. So this should not confuse you. Just I'm putting you in the hands of God, who is with you at this moment. Our Father who is in heaven, we come before your presence. We say thank you for this invitation. We'd like to welcome you into this moment, into this class. Open our mind in order to understand current electricity beyond of what it is required to understand in order to solve problems relating to the current electricity. Our Father, we like to solve problems, and these problems have been developed from the real life situation. Father, open our mind, give us courage, and give us a good understanding to understand beyond of what is going to be taught. Holy Spirit, welcome to be in charge in order to do this great business in the minds of Tanzanians, Africans, and the worldwide. We give you all the glory, Father. Myself as a teacher of this program, I give you all the glory. And even all my students who are watching this program, we have to give you all the glory and praise because you deserve. You are the one who is teaching in me. In Jesus' name, amen. So let us go into the business. So, before I go into this example 60, let me just do a quick review. Which actually that it connects session 60 with session 4 and session 5. So quick review of what? Of session 4 and the session 6. Session 4 and session 5. So basically, we have been teaching you about conduction. Conductions of what? Conductions of current electricity in metals. Okay, conductions of current in metals or in metal conductors. So then I have told you about what? So from there, we deduced it that the magnitude of current is equal to number of electrons per unit volume times electronic charge times drift velocity. Then we have what times cross-sectional area of the conductor. And the image of the conductors, we assume most of the conductors are cylinders in this way. So they have cross-sectional area, they contains number of electrons, and then there's a volume, right? At the point that you have to remember every time. But again, later on, I told you about how you can reduce the magnitude or the formula that, or derive the formula that give you the resistance of the conductor, means the resistance of the conductor against the flow of electric current. So it says it's the mass of electron, then multiplied by what? By the length of the conductor, then divided by the number of electrons per unity volume, times electronic charge square, then we have what? Times cross-sectional area times relaxation time. You should not cram these formulas. I taught you in session 4 how you can derive them. But again, in session 5, I taught you how you can use this formula and the principle of resistivity to get the formula for the resistivity. So can you remind me? Because so I have some physical students. Resistivity is equal to what?
Area.
Huh? Not the n. Number of electrons per unit volume. Times what? Give me the formula of resistivity, my dear student.
Area times resistance over area.
Pardon?
Area times resistance over area.
Guys, I'm not talking about this one. Resistance is equal to resistivity times length of a cross-sectional area. I'm asking the formula of resistivity in terms of the functions of relaxation time.
Mass.
So it's what? Because from this one you can reduce. So it is what?
Mass of electron.
Mass of electron
over
number of electrons per unit volume
electronic charge square
times electronic charge square
times relaxation time.
Times relaxation time. So this is the formula for resistivity.
Yes.
Right? We didn't do an example. Anyway, we did just some few examples in session 5, but we'll be concentrating today on how we can use these formulas to solve problems. But we didn't end there. We deduced again an expressions or the formula of finding conductivity as a function of relaxation time. But remember that, so these are the formula, another formula, we say that conductivity is a reciprocal property of resistivity, right?
Yes.
So another formula, we say that conductivity is equal to what? Is equal to number of electrons per unit volume times electronic charge square times time over what? Mass of 40 of electrons. Just from this one. Conductivity is equal to reciprocal property of resistivity. It's a form of resistivity, so if you reciprocate, you get this guy. Okay? Yes. But when I've been teaching you about session 5, again we have established an expression that resistance is inversely proportional to relaxation time. And also introduce another expressions. If you do remember, resistance is very proportional to temperature. Okay, but you deduce another expression which might be helpful for you, that resistance is very proportional to the length. And also deduce another formula, we say that resistance is inversely proportional to cross-sectional area. Physics is a beautiful subject, right? So even yourself, when you review these contents several times and while you are a fresh mindset, you can keep this information for the rest of your life. So don't think that it's a miracle. That's why we have prayed to God. All of this information can keep them so you cannot be confused and can keep on with other things in the daily life. Okay, in session 5, I left the homework. Now it's a time for me to get the feedback. Unfortunately, there is no any students until this time who have submitted the homework. So the comment section, you might be the one you can submit, but I would like to do corrections in order to open your mind. But if you want, you are not limited. This is the technique that you may use. If maybe you can find that because you are going to do the correction, you can pause the video, right? You can pause the video. You can stop the video because other students, they don't understand what the means of pause. You can stop the video and try to solve this question. The question is this one, and try to solve this homework 5, okay? And try to solve on the rough paper. Then, after you have done it, in order for you to do correction, you just continue to watch the video, and then you can do correction, and you see how correct you are, right? Remember that you have to practice in physics as long as you can. So, let us do correction, because I know this is a little bit challenging question. Before I present to you example 6, let us do correction for the questions of homework 6. Again, another thing of homework 5. Another thing that I want to tell you in physics is the study of of matter and in relation to energy. So it's a study of facts. So sometimes whenever you are doing something in physics, you have to think about the reality. Reality remain as the reality. Again, remember, if it's your first time, you have never subscribed onto our channel, remember to click the buttons of subscribe in order for you to get notifications when session 7 and 8 and 9 and 10 of current electricity will be in air or ready to be in air in telecommunications towers. Okay. So calculate, so let us read the question carefully and we try to check the keywords. Okay? Calculate the drifting velocity in copper wire. So calculate, first of all, what is required, drifting velocity in a copper wire of diameter. So you've been given what is diameter of the copper wire. Carrying a current, so we've been given a current. Current is 10 ampere. That's the first sentence of the question. Okay. Then, the next sentence, given the density of the copper, so we've been given numerical value of density for copper. Then we've been given atomic weight of the copper, which is 65.5 grams per mole. This is molar mass of copper. Every piece of information being given there is useful. And we have also to understand and remember some few concepts that you learn them consistently in chemistry. Okay? So this is the molar mass. So you've been given molar mass of 40 of copper. Assume each atom of copper contributes 1 free electrons for what? For conduction. Right? So let us go into the business solution. The first step always, because I'll be teaching you by following steps, this is the trick that I've been using for so many years, and many students, they found they have been enjoying the trick that I've been using. The first step, just to summarize the data given. okay, in order for you to know what are you lacking about. The first piece of information being given is drift velocity. So if you have done it and then you missed it, right now you can do with me or you can do correction. So drift velocity is not given, so it's required. So what you have to find. Then another piece of information be given diameter. Diameter will be given diameter 40, diameter of copper. This is the chemical symbol of copper. Diameter of copper, which you can call it, or we have a symbol of D, it's given as 1.6 exponent what? 1.6 exponent negative 3. Excuse me for some external noises that are happening at this place. Ignore them. Just focus on the session. Okay? So carrying a current of 40 of 10 ampere. Okay? So carrying a current of 40 of 10 ampere. So you have a current, so just jump from this part to this part. So you have current. I know many students, they used to quit this section. They find that they used to think that they are wasting time. But this is the trick whenever you want to master problem solving in physics. So it's 10 ampere. And then we have what? Given the density of the copper. So density of 40, density of copper. So density of copper, which is this one. So density of copper is equal to what? 9 exponent 9 kilogram per meter cube. Atomic weight of the copper, so you're being given molar mass. So you're being given molar mass. I know many students, they used to write the formula and solve the question. That's not a trick we are using in advanced physics. So in advanced physics, we like to write important information as well as we can in order to be sure. So we have, so drift velocity is not given, will be given for piece of information, and then the conditions means that we have to assume each atom of copper contribute 1 free electrons for conduction. Okay, at the first stage. The second stage, I know that many students, they can just recall the formula that can help them to get drift velocity. Okay, so to get drift velocity, okay, fine. It's right. So recall what? Recall formula, okay, of 40 of current in what? In metal conductor. So in metal conductor. So I told you how you can derive. Current is equal to what? Is equal to number of electrons per unit volume times electronic charge times velocity times cross-sectional area. So this is drift velocity. So you can make drift velocity the subject. So you have NE divided times cross-sectional area. Here we have NEN. So this one, so we find that drift velocity is equal to current of a number of electrons per unit volume times electronic charge times cross-sectional area. My dear students, I have taught more than 2,000 students the beauty of current electricity physically. But I want to tell you that in this session, God has prepared me in a different style, in a very fresh anointing that I've never taught other students. So you have a great opportunity to be taught in a high level the beauty of current electricity. So that's the formula. I know every student can reach there. Now, we can check according to the data. Are we given the current? Yes. Do we have number of volume per unit? Do we have number of electrons per unit volume? No, we don't have. Do we know electronic charge? Yes, it's constant. Do we know cross-sectional area? No, but we'll be given diameter. So always, so it means what are we missing from this formula? So what are we missing from this formula? We still have 2 unknown variables that we have to deal with them. And always, whenever you are solving physics problems, try to start from the simple concept, then go higher. So the simple concept, the simple variable here is what? Another thing that I want to tell you, I use a very different techniques. Those are the techniques that God has been teaching me. I've been using myself. I've been successful on applying them, and also I'm teaching students. And the technique that I'll be using in teaching you advanced physics, advanced any subjects, even physics for the Form 1, I use these techniques, is teaching you how you can solve a problem by following steps and write in each steps what are you doing. I know for most of the students, they can notice that is a bore. It's boring to you, but it's very important because For example, in advanced physics, we have so many concepts. So sometimes you may learn concepts, you understand, but you can forget them easily. But if you write a state, for example, we call the formula of currents in metal conductor. Later on, when you want to do the quick review, it means that, for example, can you imagine? If you jump from this line, just come here. Then, what are you doing here? So you can ask it yourself. Means that when you have a short time, it's difficult for you. That's why many students, they end on cramming formulas and cramming definitions, etc., etc. But if you write, even in your future revisions, you know what you have done here, right? So that's what I want to tell you. The second step. So the second step, we say that let us compute computing cross-sectional area. So cross-sectional area, if a big given diameter is equal to pi d square of 40 over 4. Yes, we can compute it, or we can just recall its formula and then inject all the stuff there and then wait what it's going to say. So recall what? Recall the formula of finding what? Cross-sectional area. So cross-sectional area is equal to pi d square of 40 over 4. So this is equation 2. Okay, so let me use the second column and the third column to solve these problems, so I can leave the questions on the blackboard for your review. So now from this formula we can find the cross-sectional area. Okay, so in that case we say that let us substitute equation 2 into equation 1. So substitute equation 2 into equation 1. Say drift velocity is equal to current, okay, number of electrons, electronic charge. Here we have pi d square over 4. So if this is the case, so this becomes as numerator. So you have 4 times current, or electric current. Then you have number of electrons per unit volume. We have electronic charge. Then times pi times diameter of the conductor. Right? So this in physics we say it's equation 3. So for I, then NE d square pi, this is equation 3. Okay? Afterwards, so we have this formula. We don't know the drift velocity, we don't know number of electrons per unit volume. So we go into what the force step. Okay, it's force step. You can also even call this one the force step. There's no any limitation. The meaning of steps is just to give you understanding of what you are doing. So if that's the case, the first step right now, so the first step, let us compute number of electrons per unit volume, which is the most challenging. To compute number of electrons per unit volume about the information that will be given. We are going to use the informations of 40, density of copper, and the molar mass of 40 of copper. The beauty of current electricity physically, but at high level, the beauty of current electricity. So that's the formula. I know every student can reach there. Now, we can check according to the data. Are we given the current? Yes. Do we have number of volume per unit? Do we have number of electrons per unit volume? No, we don't have. Do we know electronic charge? Yes, it's constant. Do we know cross-sectional area? No, but we'll be given diameter. In chemistry for Form 2, but recall that we say that molar mass of copper is equal to Avogadro's number of electrons. Right? Or we say that what does it mean? 1 mole of copper, this is according to the Daltons, 1 mole of copper in Avogadro's, who has been a statistic, 1 mole of copper is equal to Avogadro's constant, or is equal to, means 1 mole of copper contain Na, or Avogadro's number of 40 of electrons. And 1 mole is represented by what? Molar mass of copper. So this is the symbol for the molar mass. So it means what the molar mass of copper? The molar mass of copper is 65.35 gram per mole. So we have to express it in kilogram. So you have to convert it into kilogram. So it will be 65.5 exponent negative 3 kilogram. This is equal to what? This is equal to what? To Avogadro's number of electrons. This is the point where you find the concept. So if that the case, we want to know the number of electrons contained in the copper wire. Right? In the copper wire. So to know the number of electrons contained in the copper wire, again, we have to recall this fact. So if that the case, we say that this is equation 4. And then go to the 6th step. As physicists, we have to think differently. So then we say that recall what we taught you in the concept of the density as the second topic of physics form 1, which is measurement. So recall that we taught you density of substance is equal to mass of a volume. Right? Mass of a volume. So it means that the mass of the substance is equal to density times what? Times volume. Okay? So if that's the case, this will make your equation 5. My physical students here are not writing. I think that I'll give them another time for them to write. While according to my assessment, they missed this question. Okay. So right now we know that this amount of mass of copper contains what? Avogadro's number of electrons. Then we have mass is equal to mass of copper, means for this case we say mass of what? Of copper is equal to density of copper times volume of what? Of copper. So if that's the case, we want to see now, we want to do the comparison. Okay? So we go into the 7th step. The 7th step, we say that let us compute the number of electrons in the copper. Right? That the means of n, number of electrons in the copper. So we say that 65.25 exponent negative 3 kilogram, which is molar mass of copper, is equal to Avogadro's number. Then, what the mass now? So we have to find the given mass of this copper is what? The given mass of copper that we have to find the amount or the number of electrons which is contained is given by this formula. That mass is equal to density of copper. So it's a density of copper which we have been given times volume of copper which we don't know. Right? This one will give us the number of electrons contained. Wonderful. Physics is beautiful. So for this case, now we can cross multiplication. Right? So in this multiplication, after crossing multiplication, we have 65. I know some students are not believing. Just keep waiting. I'm not believing that what you are doing. Okay, times what the number of electrons. Then we have density of copper times the volume of copper times what? Avogadro's number. What are we looking for? Number of electrons in the copper. So we divide by 65.25 exponent negative 3 kilogram. And here we divide by what? 65.25 exponent negative 3 kilogram. Okay? So if that's the case, we say number of electrons is equal to what? Is equal to density of copper times what? Volume of copper. Then we have what? Avogadro's number. Then divided by what? Divided by what? By 65.25 what? Exponent what? From negative 3. We can compute or we can leave it. Or simply this one is molar mass divided by what? The molar mass of what? Of copper. Okay? A simple. Okay. So if that's the case, this will make equation what? Question 6. I love solving questions in this stage. It's not complications, it's just clarifying in order to meet every kind of the doubt. So we go into what? The 8th step. So for this case, it means we've been thinking about what? We are not computing, so this one, we say that, the aim is computing M. So we go into the 8th step. The 8th step, we say that, recall, we taught you in session 4, number of electrons per empty volume is given as what? N is equal to the number of electrons over volume. So we are looking at it, number of electrons per empty volumes of copper is equal to number of electrons of copper over what? Volume of copper. So this is what? This is equation 7. Okay? So because you have this information and I want you to understand, I want you to write carefully, let me clean this part. Okay, so if that's the case now, so you have to substitute equation 6 into equation 7. So that's the 9th step. So 9th step, then, okay, like this. Then substitute equation what? Equation 6 into equation 7. So number of electrons per unit volume is equal to what? Is equal to density of copper multiplied by what? Volume of copper times what? Avogadro's number divided by what? Molar mass of what? Of copper then divided by what? Divided by volume of what? Volume of copper. Right? So this makes what? This makes density of copper multiplied by volume of copper, Avogadro's number, Avogadro's constant, then divided by what? Molar mass of copper, then volume of copper. Because just you take this one divided by this one over 1. So if you are dividing two physical quantities, then you change the sign, the symbol, and this is the formula. So volume of copper cancel volume of copper. I know one of the challenges my students have encountered, how they can find volume of copper. So you've been struggling. So now, number of electrons per unit volume is equal to density of copper times Avogadro's constant divided by what? Divided by molar mass of what? Of copper. This makes equation what? Equation 8. Wonderful, right? So because you have equation 8, and here we have what? So because you have equation 8 there, we have equation 8, so we have to substitute in equation 3, right? So we go into the 9th step. Don't worry about the number of steps, just understand what you are doing. So substitute equation 8 in what? So substitute equation 8 in equation 3. So what where are we looking? Drift velocity. Drift velocity is equal to what? 4 times what? Current over what? Number of electrons per unit volume, which is what? Density of copper multiplied by what? Avogadro's constant. Then of what? Molar mass of what? Of copper. Then we have what? Then we have times what? Electronic charge. Then diameter of copper wire. Then pi. Okay? So the next step, this one becomes a numerator and the rest remains as denominator. Alright? Are you there? This is advanced physics and this is current electricity. It's beautiful, but sometimes it's paining. Okay, so if that's the case, we say drift velocity now is equal to 4 times current times what? Molar mass of copper divided by what? Density of copper. Then we have Avogadro's constant, then times electronic charge, pi diameter squared. Right? So you have all the information, just plug and play. So now, so you can even use the subscript of D just to differentiate different velocity from what? From volume. You're allowed. So you have 4. What is current? 10 ampere. What is molar mass of copper? 65.5 exponent what? Exponent negative 3 kilogram. Divided. What is density of copper? I think it is 9 exponent 3, isn't it? What is Avogadro's constant? Avogadro's number is 6.20. I had my scientific calculator. You guys, where? This one. Take your scientific calculator now. So Avogadro's constant, there's no need for you to claim. Yes, you can press constant what? Constant 24. So constant 24. Constant 4. It is 60.02.
From the question, the density of copper is 9 exponent 9 kilograms per meter.
9 exponent 9?
Yes.
No, it's 9 exponent 3.
You copied it there.
Okay, so I made a mistake. Just correct. 9 exponent 3. What is Avogadro's number? Avogadro's number, it is 60.02 exponent 23. 6.02 exponent 23. Right?
Yes.
But here we still have some other quantities. So simply I should have a long line here. Density velocity is equal to this. And density of copper it is 9 exponent 3. Avogadro's is 60.02 exponent 23. Then electronic charge it is what? 1.6 exponent negative 19. Then times what? Pi. Then times diameter. What is diameter?
1.6 exponent
negative 3. So it is 1.6 exponent negative 3 by 20 squared. So what's your drift velocity? Use your scientific calculator. Put all of those information. You'll find drift velocity. It is what? .75. Prove it. 3.75 exponent negative 4 meter per second. And if you do remember, can you go to example 4, the one that we didn't write the number? We found the drift velocity there, isn't it? How much was it? 1.560? Exponent what?
Negative 4.
Negative 4. So my dear student, from today onward, the range of the drift velocity of electrons in the conductor should be exponent negative 4. But the secret. We are revealing secrets here. So if you have got exponent negative 35, you know there's no need for you to wait the teacher to correct. So you can put a wrong one. If you've got maybe a drift velocity is exponent 9, range of exponent 9, the answer you know, but you have got an answer but it's not correct. Okay, so that's the point. How did I know that this is the range of drift velocity? Just go and do more than 5 questions asking about drift velocity for the drift velocity of electrons in the conductor. You'll find the range is exponent negative 4. It may be changed, maybe exponent negative 3, exponent negative 5, but should be within around there, right? But if you get the drift velocity is maybe 3.75 exponent 10 meter per second, it means that an electron is traveling with a very high speed compared to the speed of light, which is not correct, right? Yeah, so that's the drift velocity. So therefore, ladies and gentlemen, the right answer is drift velocity of what? Of electrons in copper wire So some students say, sir, we missed it because of the density of copper. Okay, or out. Those are the human errors. The issue is if you have missed it because the density of copper to be exponent 9, then just you can plug this one and then you get the correct answer. Then off we go. I made a mistake myself on writing the questions on the blackboard, not on the exercise book. So the velocity of the electrons in copper wire is what? 3.75 exponent negative 4 meter per second. Okay? So if that's the case, if you have any question about example 5, don't hesitate to ask me in the comment section, and don't hesitate to ask the other students in the world in the commenting section. So, ladies and gentlemen, I believe that now you are ready for example 6. Is it? So get prepared, example 6 is coming. And it's not direct questions as you may think. It's always challenging because you are advanced students who love physics. Example 7. So write to me this question quickly. A certain length of what? The length of copper wire of mass 4.5 kilogram has a resistance of 14.7 ohms. Calculate the length and diameter of the wire. And the diameter of the wire. Diameter of the wire, given that density of what? Density of copper today it is not 9 exponent 3 kilogram per meter cubic, but it is 8,930 kilogram per meter cubic, and the resistivity of copper is 1.8 exponent negative 8 mho. You know the unit of mho, what does it mean? That's the question. Remember that this is the active learning program. You are allowed to pause a video and try to solve example 7 or problem 7 on a rough paper. Then you do correction, you can stop the video, so you can spend at least 5 minutes to solve this problem on the piece of paper. Then you continue to watch the video to see or to do the correction or to see how did you succeed, or to see or to analyze your solutions compared to the correct solution that's given by Olenjolai to millions of present and future students who love physics. Okay, so let us read the questions. A certain length of a copper wire of mass 4.5 kilogram has a resistance of 14.7 ohm at the resistance of what of a copper wire. So this copper wire has been measured. First of all, think a minute, because the first sentence is talking about mass and resistance. You can stop writing and think a minute. What the mass of this copper wire? 4.5 kilogram. So 4.5 kilograms actually might be a non-copper wire, or a heavy copper wire, or a high cross-sectional height, or a thick copper wire. 4.5, 4.5? It's a weight of what? Of a bone channel. Or, okay, so it means that the first sentence. The second sentence, calculate the length and the diameter of the wire. Given that density of copper is that one, and the resistivity of copper is that one. So, solution. I believe that you have paused the video. Pause the video, it means you stop the video, then you check the correction. The first step always of Olenjolai to solve problems is let us analyze the data given in the problem first of all, to know what are we given and what are we not given. So first of all, we've been given today mass of 40 of copper wire. So mass of copper wire, which is presents at M, it's 425 kilograms. Then you have resistance of copper wire. So resistance of 40 of copper wire. So resistance of copper wire, this is equal to what? 14.7 ohm. Calculate the length and diameter. So we are looking for the length. This is required. Then another thing that is required, diameter. Diameter also is required. So we have two questions in one question. Then here's the second sentence. At the end of second sentence. The second sentence, given that the density of copper wire, so we have density of 40 of copper wire, density of copper wire. So this is 8,900, 930 kilograms per meter cube. It's nearly to 9 exponent 3 kilograms. Then you'll be given resistivity. So one of the challenge here is the symbol of resistivity and density. Handwriting sometimes it's a little bit challenging, but let us maybe use the symbol of P as just resistivity of copper. Or just, okay, we can just write a symbol of P and then having this current. Okay, so simply that's the resistivity. It is 1.8 exponent negative 8 what? Mho. Again, you have to know the range of resistivity even for the practical physics, which is paper 3 in Tanzania. You have to know the range of resistivity is always, the order of resistivity is exponent negative 8. Resistivity of the most of 40 conductors, even in practical questions. So, ladies and gentlemen, let us deal with the business that we have. We go into the second stage. How can I determine the length of this wire? So to compute the length of this wire, we say that we have to recall two formulas which are very important. So recall the formula of what? Of computing what? Computing density. So the formula of computing density, for example, of copper wire is equal to mass of copper over volume of copper. Right? But again, mass of copper is mass of copper, but this volume of copper can be expressed in terms of what is cross-sectional area of the copper wire and length of the copper wire. Right? So this one, it will be what? So volume of copper wire is equal to cross-sectional area of copper wire times length of what is of copper wire. That's the concept. So this is density of copper wire is equal to what? Mass of copper wire of what? Cross-sectional area of copper wire, length of copper wire. So this is question 1. Again, so this is all about this formula relates density of copper wire, mass of copper wire, cross-sectional area of copper wire, and length of copper wire. But in example 7, we are given also what? We are given mass of the wire, so it will be useful there, but we are given again resistance of the wire, we are given resistivity of the wire. So you have, so why did they record these formulas, or why am I recording this formula? I'm recording this formula according to the data we've been given in the question. Stop claiming physics. Stop claiming current electricity. Reinforce yourself to understand it. And God is there to help you. Because God is virtuous always. So that's the second step. So we call the formula of what? Of density. Okay, we go into the third step, ladies and gentlemen. So afterward, we call the formula that can help us to compute resistance of the wire, right? So we taught you in session 4 and session 5, the resistance, the resistance of a conductor is very proportional to the length of copper wire and inversely proportional to the cross-sectional area of copper wire. So it means that this one, so we say that resistance is equal to resistivity of what? Of copper wire times length of copper wire over cross-sectional area of copper wire. So this, ladies and gentlemen, become our equation what? Equation 2. Physics is beautiful. Should not bother yourself. You just have to follow the principles, the formulas, then you enjoy your life in physics. But remember, if you enjoy life in physics, you will enjoy on solving real life problems in the society. So ladies and gentlemen, we may go into the fourth step. So the fourth step, we say we are looking for the length. This formula contains length, this formula contains length. So you may choose either substitute equation 1 in equation 2 or substitute equation 2 in equation 1. So you have two options. Okay? So substitute equation 1 into equation 2. Okay? Substitute equation 1 into equation 2. So say resistance of the wire, the copper wire, is equal to resistivity of copper wire. But in order for you to substitute it, so this formula let us advance it a little bit, this formula, just wait. Make cross-sectional area of copper wire the subject here. Stop writing. So before you substitute, we go into the fourth step. So we say that make cross-sectional area of copper wire in equation 1 the subject. So we have what? Density of copper wire is equal to what? Is equal to mass of copper wire divided by what? Cross-sectional area of copper wire, length of copper wire. So if you make this the subject, it means we cross multiplication. So cross-sectional area of copper wire, this is given as what? Mass of copper wire of what? Density of copper wire times length of copper wire. Right? So this is just, we can call it equation 3. So now we go into the fifth step. The fifth step, we say that substitute equation what? Equation 3 into equation what? Equation 2. So equation 2, which is what? Resistance, is equal to what? Is equal to resistivity of copper wire, then times what? Length of copper wire divided by what? Cross-sectional area of copper wire, which is equal to mass of copper wire of what? Density of copper wire, then times what? Length of copper wire. Right? So this one becomes a numerator. So if it becomes numerator, in numerator we have resistivity of copper wire times what? So you have length of what? So it means that if you divide the length of copper wire become a numerator, so it will be length of copper wire square, length of copper wire square, and then we still have what? Density times density of what? Density of copper wire divided by what? Mass of what? Mass of copper wire. Okay? Are we together? So that's the formula. So now from this formula, so we have equations, we can make length of copper wire the subject. So I believe you have already finished to copy example 7. So it means our formula of resistance is equal to resistivity of copper wire times density of copper wire. Then we have length of copper wire square divided by what? Mass of what? Of copper wire. So make L the subject. So make length of copper square copper the subject. So So if you make the length of copper wire the subject, so it means that this is L square is equal to resistance of copper wire times mass of copper wire divided by what? Resistivity of copper wire, density of copper wire. So to find length of copper wire, we have to do this business. So length of copper wire is equal to square root of what? Resistance, mass of copper wire divided by resistivity of copper wire, resistivity of copper wire, then times density of copper wire. Okay? So from this formula, this will be our equation 3. So it can help us to get what the length of copper wire. Tell your neighbor, physics is beautiful. So length of copper wire, then it is square root. For the resistance, this 14 point what? 14 point? My students are not watching. 14.7. Times mass of copper wire is 4.5. Yes. Divided by what? Resistivity of copper wire is 1.8. Exponent negative 8. Right? Yes. Multiplied by what is density of copper wire? So density of copper wire, it's what? 8,930. So find the square root. So from there, we can get what? Length of what? Length of copper. Length of copper wire is what? So use your scientific calculator. If you compute it, the length of copper wire is 60.41, which is 641 meter. That's why it has a mass like that one. 600 is 641 meter, or 6.41 is for a 2 meter. So this is the length of 40 copper wire. So check your response when you've been trying. Did you try? Did you succeed?
Yes.
If you've succeeded, congratulations. Keep it up. If you didn't succeed, don't give up. Learn from mistake that you've done. Okay, so if I'm writing quickly or I'm teaching quickly, you can pause the video and copy the notes, then you move on. So, ladies and gentlemen, we are done with SOT. We are done with computations of length of the copper wire. So because of length of the copper wire, now we have an assignment to compute the diameter of the copper wire. We have different alternatives or different techniques to follow. So this will make the sixth step. So the sixth step to compute diameter, we call it the formula for it. The formula that help us or show relationship between resistance, okay, the formula for it of resistance, and this is resistance is equal to what? Resistivity of copper wire times length of copper wire that we have already computed over cross-sectional area of copper wire. But cross-sectional area of copper wire is given as what? So density of copper, resistivity, excuse me, this is not density, it's resistivity. We agreed to use this symbol. Okay? So this is resistivity of copper wire. Then we have times length of copper wire divided by what? Cross-sectional area of copper wire, it is pi diameter of copper wire square over 4. So resistance of copper wire is equal to what? Is equal to 4 times resistivity of copper wire times length of copper wire over what? Over pi diameter of copper wire square. So what are we looking for? Diameter of copper wire. So we say that make diameter of copper wire the subject. So to make it the subject, we have diameter of copper wire square is equal to 4, then density, resistivity of copper wire, length of copper wire, divided by what? Pi over resistance. Then have to find the square root now to get the diameter. So it means diameter of copper wire is equal to what? Square root of what? Square root of 4 resistivity of copper wire, length of copper wire, over pi times what? Resistance. So now we have the formula. We have just to compute the diameter of the copper wire. I believe up to this moment you're enjoying the beauty of physics, the beauty of current electricity. Physics is beautiful. So this is 4 times what? Density of copper wire, no, resistivity, excuse me, this is resistivity of copper wire times length of copper wire divided by what? Pi times resistance of the copper wire. So diameter of copper wire is equal to square root of 4 times resistivity of copper wire, which it is what? 1.8, isn't it? It's from -8, multiplied by length of copper wire, which is 441, which is 641, divided by pi times resistance of copper wire, which is 14.3 ohm. Right?
14.7.
14.7. 14.7 ohm. So use your scientific calculator to do your computation. Therefore, diameter of what? Diameter of copper wire is, so use your scientific calculator to do computation. If you have lost it, don't worry. Into ASO, we are also providing, or we are also shipping, or we are selling and distributing original scientific calculator. So the diameter of copper wire is 9.996 exponent -4 meter. 9.996 exponent -4 meter. So it is in terms of what? Millimeter. So remember, diameter of wire can be vary. Don't think that diameter of wire is like electric velocity or like resistivity of wire, right? Diameter of the wire can vary. Depends on the thickness of what? Of the wire. Okay? Is physics beautiful? Some of them say, yeah, somehow. Okay. Whatever your response, I want to tell you that this is the match you have to play. So, ladies and gentlemen, if that the case, you can allow me now to present to you example 8. Problem number 8. Should not get tired. And this problem number 8 is a question from Advanced Certificate Secondary Education Examination of 2005. 2005. Don't know where is my what? 2005. Because also we have books distributed to our students. So these past papers are very important for you to learn, so you can take it in order to realize the facts. I want to tell you that in Tanzania Online Advanced Secondary Schools, in square bracket Olenjolai M, we are also equipping our students with books. So this is the sample book that's called the Advanced Physics 1 Review. It contains questions and answers from 2003 to 2016. So this question now is come from paper 1 of 2005. 2005. So 2005. So when I'm writing, let me ask you, one of my students, to open a exam of 2005. So this is the example, this one. So it's Advanced Certificate Secondary Education of 2005. Paper 1. So this is a file. Okay. The question said that, okay, it's a little bit concepty for the way it is, because you have to think, and also you have to think and remember what we taught you in basic applied mathematics or in advanced mathematics. So the question states that current in a wire, if we don't teach you these kinds of these types of questions in class. When you find them in exams, it will be a surprise for you. Varies according to the relation. According to the relation, which is current is equal to 4 plus what? Plus 2t squared. 4 plus 2t squared. Then you have Roman 1. How many Coulomb? How many Coulomb pass across the wire? How many Coulomb pass across the wire in a time interval when you open paper 1 of 2005, just got the questions of current, which I guess is in section B, interval between t is equal to what? T is equal to 5 seconds and t is equal to 10 seconds. That is Roman 1. Roman 2, what constant current would transport the same charge in the same time interval? What constant current will transport the same charge What current will transport the same charge in the same time interval? The same time interval. So this is the question we have to answer. Do you find it? Yeah. This question number 10. Number 10. So it means to be far. So let me write it accordingly. The good thing is I have some physical students. One of them, his name is called the Johnson, Zakaria, and the other one is called the Joshua. So I gave them to open in order to prove that what I'm telling you is true. So the far advanced certificate secondary education for international students, this is it's abbreviations of national advanced exams for Form 60 students in Tanzania. Should not confuse with this referencing because it's not important for you. The issue is just you can deal with the question. For the international students, for the Tanzanians, they are happy to see that we are solving some of the questions appeared in NECTA or in the final exams of advanced physics. So the far advanced certificate secondary education of 2005, paper 1. We have 3 papers in Tanzania. Paper 1, paper 2 of physics, paper 3. So this is paper 1. Section B. This is it, Johnson? B or C? B. Question number 10. Question number 10. So you can order this book. You can order any book. We have so many. We have a library that we call Tanzania Online Advanced Library. TOA. This is TOA. This is O-level library. So for A-level library, its abbreviation is what? TOA. Tanzania Online Advanced Library. So there we are equipping our students with notes. We are equipping our students with books such as Roger Mancaster, which is actually called the Principle of Physics, what's called Advanced Physics, Nelcon. So you have so many books. So how you can order? Just send a message of your order. So this telephone number 0759 745331. Just send a message and then I'll call you. Then we make a business and we can ship these books or we can send to you in any region of United Republic of Tanzania. Even if you are studying advanced physics in Unguja, you can order books from our online bookstore. And believe me that we are faithful, because this work it's a work of God for us, so God is in charge. So don't worry about your money. We'll try our level best to make sure that you get high quality products in order for you to learn advanced subject in peace of mind. So the question, let us read. How many sentences do you have? We have almost 3 sentences. So listen carefully. Current in a wire varies according to the relation, which is current is equal to 4 plus 2 times time squared. That the variations of what of current in a wire. Right? So it means the variations of current in wire depend on what? Time. Right? Then the first question, how many coulomb pass across the wire in a time interval between 5 seconds and 10 seconds? Coulomb, how many coulomb? Coulomb is the SN40 quantity of charge. So how many charge pass across the wire in a time of the interval between 5 seconds and 10 seconds? And the majority current carriers, or the current carriers in conductors, we say are what? Electrons. But the current carrier in the conductor, that's the electronics, are electrons and the holes. So you have to distinguish, because in physics we have conductors, semiconductors, insulators. Insulators, they don't conduct electricity at all at the room temperature, but if you increase temperature to the max, which means to the higher level, then you can force insulators to conduct electricity, but in a very difficult way. But semiconductors conduct electricity by using electrons and holes, while conductors, which are learning current electricity, conduct current by using by flow of 40 electrons. So remember, conductors, they do conduct electricity by flow of electrons, unless you have been told in the problem that also protons participated in flow of electric current. Does it make a sense? Yeah, thank you. So we have these problems. It's not a difficulty question if you have met it, because this is just like, for example, if you want to play to be a victorious as a team in a particular league, you have to make sure that you do hard practice or very difficult exercises, which will Do you know the second match? Applications of all of this information in solving real life problems. How about in your accounting? Let me in the comment section. So ladies and gentlemen, you can pause the video by using the principle 40 or the active learning principle, right? You can pause the video, you can stop the video, You can try to solve these questions on your rough paper, and then you come back to continue to watch the video as the corrections of your trial. Alright? Can you do that? I ask you, please, I'm not there, but God is there. Please, try to solve this question. Imagine Olenjolai did not teach you. Imagine your class teacher did not teach you, but you went to exams and you failed. Would you like to lose 5 marks because of failure to try? No, you can try. You have to think differently. So, ladies and gentlemen, I believe you have tried. So now, let us solve the problem. Current in a wire varies according to the relation that one. Always Olenjolai start with sorting data given. This technique of writing data or data given we've been taught since ordinary secondary education, but when we reach to advanced, we say we are advanced, so no need of data given. That's why we are missing most of the questions. Data given. The first thing that we've been given, we'll be given equation, right? Equation that show variations of electric current, which is I is equal to 4 plus 2 t squared. So where t represents time. That's the first that has been given in the first sentence. It's a very important data, and I will show you why it is important. For you, it is meaningless, but for we physicists, that's a very important data, and it's possible. So maybe you can find another kinds of the equations. It can be, this is just like a quadratic equation because the highest means the highest degree it's 2. So find any kind of the questions. So when I'm teaching you, I'll be teaching you this single example, but whenever you find any questions or any relations between current and time, you have to use the same principle or the same technique that I'm going to teach you, right? So regardless of maybe it can be 40 plus 60 plus maybe 2t squared, you should not worry. Just applying the following principles or the following steps, then you solve the problem. Okay, so we got the second. So how many coulombs? So we've been asked the coulomb. And coulomb, actually that we have been asked to find quantity of charge. So how many coulombs across the wire in a time interval? So coulomb is what we are required to find in Roman 1. But we'll be given time. And this is time 1. So time 1 is 5 seconds, which you call initial time. But we'll be given time 2, final time, which is 10 seconds. Okay? So you can write also the data for what is, so what constant current will transport the same charge in the same time interval. So again, we need what to find what is constant current. So constant current, because we say you can have variant current, constant current is I. This also is what is required. So I have the data in the first main sentence in Roman 1 and Roman 2. Right? So in that case, we go into the second step. The second step, we have to find the coulomb. The coulomb. Recall, first of all, recall relationship or the formula. The formula relates, or the formula that relates what? Or the formula that relates current, quantity of charge, and time. So we taught you since physics form 2. The formula, we say current is equal to what? Current times time is equal to quantity of charge. Okay? So let me just write it this way. Quantity of charge is equal to current times charge. What if the time will change? Because here time has changed from 5 seconds to 10 seconds. So if times will change, also the quantity of charge will change. So you have small change in quantity of charge. Current is constant. Then there is also small change in what? In time. Right? So in physics, by applying the concepts of mathematics, this small change in charge, we write it dq, delta q. This also is equal to constant current times what? dt. So this is still not an equation. Remember that this is equation 1. So this is equation 1. So let us make I the subject. So we divide by dt, and then we divide by dt. So this one and this one cancel. dq of what? Over dt is equal to current. Right? So this is what? Equation 2. Then, Olenjolai has taught you, whenever you have equation 1, equation 2, always those equations they can relate. That's the technique. That's why we have them. So we go into the steady state. The steady state, we say that let us substitute what? Equation 2 into what? Into equation 1 above. So what is equation 1 above? We have I is equal to dq right now, over dt is equal to what? Is equal to 4 plus 2. So remember that I wrote these questions a little bit concept. The meanings of concept, when you reach this question, you have to slow down your speed. There's something new there. Compare it to the previous examples. That's the meaning of just giving you an alert of what of concept. Alright? Is it correct? Everything's okay? So from this case, we can multiply by changing time to both sides of this equation, new questions, which is question 3. So you say change in quantity of charge is equal to 4 plus 2 times square dt. So this is equation what? This is equation 3. Okay? To find the amount of what? The amount of coulomb pass across the wire in the time interval between 5 seconds and 10 seconds, then we go into the force state. The force state, we say that apply integral sign, apply integral to both sides. Okay, apply the finite integral. Let me specify the finite integral. It means interval with limit. The finite integral to both sides of 40, both sides of equation, both sides of equation 3. So if you apply integral, we're integrating from 0 to quantity of charge of 40 of dq. And also we have to integrate from, so here we integrate with respect to what? To time. So the given time is 5 seconds to 10 seconds. So this is 4 plus what? Plus 2t squared. Then what? Dt. So you're integrating with respect to or variable for interval, it's time, and here variable of interval is what? It's q. So now the next business, integrate the given problem. It's not difficult. It's not difficult. So to integrate this one, we say that we may consider left-hand side firstly. So this is equation 4. Yeah, this is question 4. So consider what? Consider left-hand side of equation 4. So consider left-hand side of equation 4. So left-hand side we have integral from 0 to quantity of charge dq. This is equal to, if you are writing integral from 0 to q, we have q power 0 dot dq. So if integrating with respect to q, listen careful. We say that this one, when we're integrating, we get what? So we say that the integral from 0 to q, dq, listen carefully if you have forgotten basic applied mathematics or advanced mathematics. So this integral gives us what? The variable is q, so you have q power 0 plus 1 of what? 0 plus 1. And hence the limit are from 0 to q. These are the techniques of the finite integrals. So it means that integral from 0 to q of what? Of dq, this is equal to what? So 0 plus 1 is q power 1. So here it remains is q because 0 plus 1 is 1. So then we have lower limit is 0, upper limit is q. So we have to substitute Q in this Q. So it will be Q. So you substitute the upper limit, then we minus the lower limit. So Q, substitute Q is 0. So this will make what Q. So simply you say that integral from 0 to Q. I know that I'm teaching PCB students who actually are not, I don't want to say that I'm not good in advanced mathematics, but sometimes it's easier for them to forget and find that they are completely confused with this simple stuff. Or maybe they have been taught it wrongly, or they have been taught it in a very difficult way while we are here, and the responsibility of engineers like Olenjolai is to simplify the stuff. That's my responsibility as we are teaching. So on the left hand side, the integral from 0 to Q of dq, which is Q. But sometimes we have those students who actually they want the simplest way to solve the stuff and leave the place, right? So for those students who don't love, who unfortunately they don't love mathematics, we used to teach them this technique, okay? Because I had some of them, but in engineering categories, okay? So we say that whenever you're integrating dq, for example, we used to teach them the simplest way. Instead of remembering all of those stuff, right? So you can just cancel this integral sign with this small change. Then the answer is what remains, so it is Q. That's the answer. That's all. Wonderful. Okay. So then we are done with left hand side. So we go into what is the sixth step. The sixth step, we say that considered. Now let us consider right hand side of what? Of equation 4. The right hand side of equation 4, we have to integrate from 0 to 10. We have 4 plus 2t squared dt. So it means that we have to insert the integral sign. If you find that I'm writing quickly, I'm teaching quickly, you can pause the video, you can watch this video several times, so you should not be confused. So on the left hand side, we have a Q, that's what you've got after integrating, is equal to integral from what? From 5 seconds to 10 seconds. Oh, excuse me, here I made a mistake, we're integrating from 5 to 10. So even my students, they didn't see. So 5 to 10, then we have what? So here we have 4 plus what? 2t squared dt. So it means that we can open the bracket. So if you open the bracket, we integrate from 5 to 10. Then we have what? We have 4 dt plus what? Integral from what? From 5 to 10. 5 to 10 of 2t squared dt. So listen careful how we're integrating them. These are very simple integrals for students who are doing basic applied mathematics. So let us integrating each part itself. So for this part, let us take a constant which is 4, take it out, integrating from 5 to 10, then have what? dt, plus. Here too it is constant, take it out, integrate from 5 to 10, then what? t squared dt. Right? So let us stop writing. It's time for integrations. I want you to enjoy integration. Okay. So how do you integrate this? Integrate dt is just like how we integrated the dq. We integrate dq, the final response is q. So if you integrate dt to simplify your life, because I know you are tired with these kinds of integration, so you get 4. Then if you integrate dt, because here we have t power 0, so if you integrate t power 0, you get t power 0 plus 1 over 0 plus 1. And then here we have limit is 5 to 10 plus 2. Then now we are integrating t squared with respect to t. Then we have to apply the principle we taught you in advanced mathematics or in basic applied mathematics. If you have never heard about these integrations, I have a good news. I'm teaching also basic applied mathematics for the students who are doing PCB, who are studying physics, right? But for those students who are studying pure advanced mathematics, I'm also teaching integration for the Form 5 students. So you should not worry. But up to this level, when I'm learning about current, you should be aware about advance. But I'm talking about some international students, so maybe they don't have integrations in the year level, but they want to master current with this stuff. So now, if you integrate this stuff, we have t power 2 plus 1 over 2 plus 1. Then we integrate from 5 to 10. This is lower limit, this is the upper limit. Right? We are still computing the number of coulombs that will pass across the wire. So we have 4. Here we substitute the upper limit in t. So the upper limit is 10. So if you substitute there, we have 10 minus the lower limit, which is 5. So here we have 5, ladies and gentlemen. Then for this case, before we substitute the limits, we have to do a simple algebraic computation. We have t power 3 over 3, then we integrate it from 5 to 10. Wonderful! Then quantity of charge Q is equal to 4, 10 minus 5, it's 5, plus 2 over 3, this one. Then we have t squared. So here we mention t squared from 5 to 10. Quantity of charge, that is Roman 1, the answer for Roman 1. 4 times 5, it is 20, ladies and gentlemen. Then here we have 2 over 3. Then here we have t. So substitute 10 in t. This makes what? 10 squared. Minus what? Substituting 5 in t as a lower limit. This is makes 5 squared. So quantity of charge is equal to 20 plus what? 2 over 3. Then there we have 100 minus 25. Right?
After integration.
Oh, excuse me. This is t cubic. Thank you for notification.
Yes.
So t cubic. So here we have 10 power 3. And here we have 5 power 3. Thank you very much. Okay, thank you very much. So 10 power 3 it is what? 1,000. Minus 5 power 3 it is what? 125. That is your show, which is inside the class. Okay? So quantity of charge, this is 20 plus what? 2 over 3. Then 1,000 minus 125. What do you get there? 800. You are looking at scientific calculator. Just simple computation. 10 minus 5, it's 5. Then you have 9. 9 minus 2, it's 7. Right? Then remains what? 9. 9 minus 1, it's 8. Isn't it? Huh?
Yes.
So if you divide and add the terms, what do you get?
600.
So quantity of charge is equal to My students are still sleeping, unfortunately.
603.333.
603.33 what? Members?
Coulombs.
Coulomb. So 333 Coulomb. So simply now we conclude. Don't write this way and then leave it, because the questions did not ask you about Q. Questions ask you about the number 40 of Coulomb. So you say, therefore, the number of Coulomb passing, okay, through what? So through a copper wire, or is it named? Is the wire named?
Sir, that is not the number of coulombs. It is the quantity of charge.
Yes. What is this? These are Coulomb.
Okay.
It's a trick. It's a trick of asking questions. The number of Coulomb passing through the wire, okay, from what? From 5 seconds to 10 seconds is what? 603.33 Coulomb. But this is the response for Roman 1. Roman 2, we've been asked what the constant current that passing through the wire at the same interval, right? So to get constant current, so this will be step number what? So the integrations has absorbed all our steps, eh? So this is 7 steps. So 7 steps. So second stage, we say that we call the formula that relates constant current, quantity of charge, and the time. And then we have already called. So we say that quantity of charge is equal to current times time. If quantity of charge will change, which is the Q, then also this will be influenced by the change of time. So we are looking for this constant current. So then we say that divided by what? dt. And here we divide by what? By dt. So we say that the constant current, here we have a quantity of charge dq over dt. We have found dq is equal to q within the interval from 5 to 10. Right? This also, it's the same formula if you're writing change in quantity of charge over change in time. But we have found already change in q, so which is q over change in change in time. So change in time, we say that this is q over what? Time 2 minus time 1. So constant current, ladies and gentlemen, will be equal to 603.3 Coulomb divided by what? Change in time, which is 10 minus 5. So what will be the response?
120.
120. 120.what?
67.
67 what? Members. You always forget the SI unit. Any physical quantity which does not, any physical quantity or any value of a physical quantity which is written without its SI unity is meaningless in physics. So SI unity is very important, more than you think. So if we're doing computing current, you know the SI unit of current is ampere. So the answer for Roman 2, keep writing please, say that constant current flowing in the wire is what? 120.67 ampere. You are done. So for the excellent students is going to look for more questions about that concept. Okay, are you ready for example 9? Ladies and gentlemen, let me present to you example 9, which is not difficult, it's simple. If you remember session 8 and session 10, session 8 or session 4 and 5, the question states that if you have any question, don't hesitate to ask in the comment section. Resistivity of copper wire at room temperature. Resistivity of copper wire at room temperature is 1.7 exponent negative 8 mole. Or ohm. Is it ohm per meter? Ohm meter. Yeah, ohm meter. If the density of mobile electrons is 8.4 exponent 28. Exponent 24. 28. Exponent 28. Per meter cubic. These questions show you the applications of the formulas that we taught you in previous sessions. Find the relaxation Find the relaxation time for free electrons. For free electrons in copper. So resistivity of copper wire at room temperature is 1.7 exponent negative 8 mho. If the density of mobile electrons is 8.4 exponent 28 per meter cubic, find the relaxation time for free electrons in a copper. Very simple question. Then pause the video and try to solve this, or problem number 9 on the piece of rough paper before we do the correction together. So let us read the question carefully. Resistivity of copper wire at room temperature is 1.7 exponent negative 8 mho, or reciprocal form. If the density of the mobile electrons, read careful, if the density of mobile electrons is 8.4 exponent 28 per meter cubic, find the relaxation time for a free electron in a copper, in a copper wire. Find relaxation time for free electrons in a copper wire, or a copper conductor. Solution. I believe you have paused the video and you have tried. The first step for solving problems in physics, followed by Olenjolai, is data given. And when you read problems in physics, you read them sentence to sentence. Resistivity of the copper wire at room temperature is 1.7 exponent negative 8 mho. That's the first sentence. So the first sentence, the aim is to give you the value of resistivity of copper wire. That's all. So the first data you're being given is resistivity of what? Of copper wire. So resistivity of copper wire, which we say that, let us write it this way, is equal to 1.7 exponent negative 8 mho. If you remember, I told you that the order for resistivity of conductors or of wires in physics is exponent negative 8. You see again, right? Let us go into the second sentence. Stop writing. If the density of the mobile electrons is 8.4 exponent 28 meter, that's the second sentence. So listen, when you hear the word density, because you are limited, or you are limited mind, you might think that the density that you know is only mass over volume. But that is not a density, means mass over volume. Density, it means that, sometimes density, it means that accumulations, means that the amount of things that which are found in that thing, right? So if it does say that the rooms had a high density of people, so it means that it had a large number, 40 of people. So this means that the number of electrons per unit volume. But otherwise, you can write density is equal to mass over volume, then volume is not known, then you trouble a lot. Because if it is density, it means density, it should be, the unit should be kilogram per meter cube. So the second information that you're being given is density of 40 of electron, density of 40, density of electrons, which means number of electrons per unit volume. It's given as what? 8.4 exponent 30 exponent 28 per meter cubic. If you want to realize that this sentence is true, just to check example 5. In example 5, we are trying to compute the value of n. However, that we injected it into the general formula, but you can compute n. So if you compute n in example 5, you can compare you will see this, the order of number of electrons per unit volume. Students, listen what I'm telling you. This is the trick I used myself, and this is the trick I teach my students. Some of the physical quantities in physics are constant, are categorized in terms of order. Right? It's just like if you'll be given a problem to find the speed of light, then you find the speed of light is re exponent 20 meters per second. Is that true? No. So that is the number of electrons per unit volume. So you finish the second sentence. The second sentence, find the relaxation time of free electrons in the copper wire. Aha! So I've been asked to find relaxation time, which in current electricity notates as a small t. That is what required. Okay? The second step, we have to recall what? To recall the formula that relates what? Relates resistivity, and what? And number of electrons. And number 40, a number of electrons. Resistivity, a number of electrons. Do you remember it? Do you remember the formula? I reviewed in a quick review, but if you've forgotten, just to go the beginning of session 5. If you are writing, you have read the number of sessions, very important, on your exercise book. Just to go to the session 5. Go at the beginnings of session 5, you students who are here. If you go at the beginnings of session 5, you will see that we have derived the I and U, the formula of resistivity, in terms of mass, is equal to mass of what? Of electrons, of a number of electrons per unit volume, then times what? Electronic charge square, multiplied by what? Relaxation time. That's the formula. So from the formula, the remaining informations are constants. Right? So from this formula, which you can call it equation 1, but you can say that, okay, so you go into the third stage. So make it relaxation time the subject. So if you make relaxation time the subject, then you say that relaxation time is equal to what? Mass of electron of what? Number of electrons per unit volume, electronic charge, then you have what? Resistivity of copper wire. Okay? Then we need some constant. So it means that this formula make this one subject to. Okay, so you can call it. This is the formula that you have to use it, but we know mass of electron is equal to constant to 0.3. Check in my calculator.
Yes.
So it is 9.1 negative 31 or 30. Check.
31.
Check. Then we need what? Electronic charge. So 1.6 exponent negative 19 coulomb.
31.
31. So we have all the informations, we just plug them there, then we are done. Don't think that every question of current electricity is difficult. Because I know some of my students, they say, today, how are we going to solve this problem? Don't think that every problem is difficult. Some of them are straightforward. Okay, so it means that now relaxation time is equal to what? Is equal to mass of electrons, which is 9.1 exponent to what? Negative 31 of what? Of a number of electrons per unit volume, which is 8.4 exponent to what? Exponent 28 multiplied by electronic charge, which is 1.6 exponent negative 19 square. Then you have multiplied by what? Resistivity, which is 1.7. 1.7 exponent negative what? 8. Negative 8. So relaxation time is equal to what? Use your scientific calculator to compute it. So what?
2.49.
2.35 exponent what? Compute. That is relaxation time.
.49 exponent negative 14.
2.49 exponent
Negative 14 seconds.
negative 14
Seconds.
seconds. So what can you notice? Relaxation time is very small because it is in the order of exponent negative what? 14. It's 0.0000000000 until you get 14 0, then you put 249. Right? So therefore, relaxation time of electrons is 2.49 exponent negative 14 seconds. Okay, are you tired?
No.
Is it enough for you? Have you solved enough problems on metallic conduction? Have you solved enough problems? So can you go further yourself?
Yeah.
Eh?
Yes.
Are you sure? Yes, what you are saying, yeah. Let me put one example, then you challenge yourself and just think if what you could do, you should find this one. So let me do the last example, then I'll give you 2 questions for the homework. Then we'll call the day. It will be the end of session. Ladies and gentlemen, let me present to you example 10, which is this concept. A copper wire of diameter 1 centimeter has a resistance of what? 0.15 ohm. It is drawn under pressure so that its diameter is reduced to 50%. What is new resistance of wire? What is new resistance of what? Of wire? That's the question I have. Physics is physics. Tell your neighbor. Physics is physics. You might think that this is a straightforward question, but it's not a straightforward question. There is a concept there. You have to be careful. A copper wire of diameter 1 centimeter has a resistance of 0.15 ohm. It's drawn under the pressure so that its diameter is reduced to 50%. What is new resistance of wire? So you have to be careful there, because you should know the principles of, we used to call it principles of strength of material. If you do remember about back modulus, do you remember? So back modulus, it means we can compress the substance and then we change some parameters. You have to understand, because this has been submitted, it has been subjected under pressure to reduce its diameter. So you have to know the facts in physics. Tell your neighbor you have to know the facts in physics. So this is the wire. So let me take a wire, because I want to teach you and present the situation practically. So you can pause the video and try on the graph paper. Then after you try, you can keep watching the video and see the correction. If you succeeded, congratulations. If you missed it, that's the process of learning. But, okay, so I believe that you paused the video. Thank you for trying. Now it's a time for doing correction. You remember the first step of Olenjolai, and this is called the data given. So the data given, we extracted them from sentence to sentence of the given problem. That's the trick. Every sentence represents something. Even if you've been given a long questions, but just analyze the questions in terms of sentences. Okay? A sentence, in most cases, is ended by a full stop or a question mark. Right? So let us start with the first sentence. Are you ready for that? These are the tricks, because I'll be using different teaching aids. I'm using different teaching techniques. So these are the techniques, right? Which simplify the life of millions of students. A copper wire of diameter 1 centimeter has a resistance of 0.15 ohm at the end of the first sentence. So you write the data given there. Copper wire of diameter. So you'll be given diameter of a wire, which is D, is 1 centimeter. Then we'll be given this resistance. Resistance of the wire, which you can call it generally R, it's 0.15. 0.15 ohm. 0.15 ohm. It is drawn under pressure so that its diameter is reduced to 50. So that's the end of the first sentence. We go to the second sentence. It is drawn under pressure. So what the meanings of it is drawn? It is drawn under pressure. For example, suppose that this is a copper wire. This is the wire. Or this, yes, copper wire. So today it means that the keyword is copper wire. Can you call your firstborn copper wire? Yeah, so some of students say, yeah, I will call my firstborn copper wire, because the real both are in current electricity. So suppose that this is the copper wire, and its length, its diameter is 1 centimeter. Suppose the diameter. So diameter, it means that the distance from this side is from the top to the bottom, right? And then its resistance is 0.15. It's going to be subjected in what? Under pressure. The means of it is going to be subjected under pressure in such a way its diameter is reduced by 50%. So if you subject it means you compress. This wire is going to be compressed in such a way that its thickness is going to be reduced. But you have to know, if the thickness is going to be reduced, then something is going to change also. Right? So the thickness has been reduced in such a way that the new diameter of the wire is reduced by 50%. 50% of 40 of original diameter of the wire. What the original diameter of the wire? 1 centimeter. What the 50% of 1 centimeter? It's 0.5 centimeter. Wonderful. Physics is beautiful. But remember, we prayed to God. So God is working. Tell your neighbor, God is at work. So according to the second sentence, means we have two diameters. So we are allowed as physicists to call this one diameter 1. So the second sentence gives us a new diameter after compression. So a new diameter, which this one we call T40 diameter 2, which has been reduced by 50%. 50% of 40 of diameter 1. So 50% of diameter 1 means 50 over 100 multiplied by diameter 1, which is 1 centimeter. So this will make it, so this is 0.5 centimeters. So it means that the 2 is 0.5 centimeter. Very important information. Okay, so we go into the third sentence. What is new resistance of the wire? New resistance. So we had all the resistance or resistance before subjecting the copper wire under pressure, and so this one can call it R1. And this new resistance can call it R2. That is what required. Okay, those are the information being given. We are physicists. We love physics. We have to solve the given problem. Okay? So we go into the second stage. According to the information will be given, the information will be given is relating to physical quantities, which is diameter and resistance. Right? So when you talk about diameter, if you remember what I taught you in session 4 and session 5, it talks about cross-sectional area of the wire. But do you have any formula that relates only resistance and diameter? If you do have, that's fine. We do have. But I don't want to confuse you. Maybe you can have. We do have. Okay. So because we do have, let me open your eyes how we solve this problem. You can use also the general formula or the relation, the formula that relating resistance, length, and the cross-sectional area. But when I'll be using this formula, which relating only resistance and diameter, you have to understand, listen, this is the principle. Whenever we are subjecting a wire of a particular diameter under pressure to reduce its diameter, then length is going to increase. You are compressing this, so it means that you are stretching it. Diameter will decrease, but length will increase. So because diameter has decreased, at the same time when diameter is decreasing, length is increasing. So we say that the volume of the wire is conserved. The volume of the wire before subjected it under pressure is the same the volume of the wire after subjecting the wire under the pressure. Why? Because volume is equal to cross-sectional area times length. Right? So cross-sectional area is equal to pi d square over 4 times length. So if you decrease the diameter, at the same time you increase the length, you conserve the volume. Are we together? Do you get my point? Understand that? So you may use the normal formula, or you may use the formula that I'm going to teach. So we have two alternatives to solve this problem. Because of the time, and I've been teaching almost now, it's more than 1 hour and a half. I don't want to do both of the method. But you may do the second one. Let me do the first one. We do have a formula, so you say that we call formula that relates resistance and the diameter of the wire. Do you remember its formula? We say, I told you in session 5, resistance of the wire is inversely proportional to cross-sectional area. So if that's the case, if you make the proportionality sign, resistance of wire is equal to constant over cross-sectional area. Right? So the resistance of wire before subjecting the wire under pressure is, we call it resistance 1, and cross-sectional area also will be cross-sectional 1. So it means that resistance now is equal to constant K over cross-sectional area. What is what I told you? Cross-sectional area is equal to pi d square over 4. So resistance is equal to constant K over what? Pi d square over 4. This makes 4K over what? Pi d square. So resistance is equal to what? It's make constant the subject. So you say that resistance times pi d square over 4 is equal to constant K. So we say that before compressing, before subjecting the wire under pressure. So we say that we have what? Resistance 1, and you have what? Resistance 1, pi it is constant, and also you have diameter 1. 4 is constant. Is equal to what? To constant. So this is what? This is the same thing. So this is question 1. So I say that the first step, after what? After subjecting the wire under pressure. For subjecting the wire under pressure. So we have resistance 2 and diameter 2. So we have the same equation but with different subscript. So you are going to have what? Resistance 2 times pi, which is constant, diameter 2 square over what? Over 4, which is equal to K. This is question 2. So you go into what is the first step. So the first step, we say that equators. Let us equate equation 1 and equation 2. So to equate, you have resistance 2 pi d2 square over 4 is equal to resistance 1 pi d1 square over 4. So 4 pi. Right? So you have what? Resistance 2 times diameter 2 square is equal to resistance 1 diameter 1 square. What are we looking? New resistance. Resistance 2 is equal to R1. We have d1 over d2 square. Right? Then, we physicists will solve a problem. We enjoy. What's R1? R1 is 0.15 ohm. What's diameter 1? It is 1 centimeter. What's diameter 2? It is 0.5 centimeter. Then what? We do square. Centimeter cancel. So what is R2? R2 is equal to it?
0.6.
So this to become there, so it is 0.6 or 0.3?
0.6. 2 squared is 4 times.
Yeah. Okay, so it is 4. So 4, so 0.6 ohm. I forgot that square. So the answer we've been asked what? The new what? New what? Resistance of a copper wire. So physics, if you understand, is beautiful. If you don't understand, is painful. It's not beautiful. So we say that the new resistance of a wire is what? 0.6 ohm. Now it's a time for the homework. It's a time for the homework where most students used to quit because they just want a teacher to solve problems for themselves, but they don't want to solve for themselves. So I have 2 questions. One question I'm going to write on the blackboard, the other ones I'm going to read. We learned dictation, so we are going to apply it. Dictation. You remember the concept of dictation? Right. So it's a time for the homework. This is homework what? I used to name homework according to the session, homework 6. And we have 2 problems. These are, let us start with example 11, which will test you are understanding on what I have been teaching you. Are you ready for the homework? Are you ready? Are you ready? Are you ready for the homework? Are you ready for the homework, my dear student? Are you ready for the homework? Are you ready for the homework? So, be careful with this question. In a discharge tube, the number of hydrogen ion let's say protons. Have to be careful with this question. But you say that you are ready now to try. And I love students who are trying. Make sure that you do this question and submit your homework in the comment section. Drifting across means that the number of hydrogen ions drifting across a cross-sectional area per unit second. Drifting across section, per unit second. Per unit second is 1.2 exponent 18. While the number of electrons drifting in opposite direction is 2.8 exponent 18 per second. If the supply voltage is 220 voltage, what is the effective resistance of the tube? What is the effective resistance to the tube? At the question. Then we discussed it together that example 12, which is the second question, I'm going to dictate it. So get prepared to listen. In case that you find I'm speaking quickly, you can watch the video several times and listen it so that you can write, because I want you to be an active student. Are you ready for that? Are you ready? Are you ready? Are you ready? Are you ready? But this is concept also. You have to be careful. 1, 2, 3, let us start. A wire with resistance, of 5 ohm is drawn, passive participle of draw, is drawn out so that its new length is 3 times its original length. Its new length is 3 times its original length. Let me repeat that sentence. That is one sentence. Then you put the full stop after writing the word length. A wire with resistance of 5 ohm is drawn out so that its new length is 3 times its original length. Then you put the full stop. Then the second sentence, find the resistance of the longer wire. Find the resistance of the longer wire. Let me repeat the whole question now. A wire with resistance of 5 ohm is drawn out so that its new length is 3 times its original length. Find the resistance of the longer wire. If you manage to do that questions to make 12 examples, I ask you, physical students who attend this class, physical and online students, you have to make sure that in a month you have found also new 12 questions or 12 examples about conductions of electricity in metallic conductor to add up with this at least to have 24 questions. It's possible. Within a month. Or not within a month, within 2 weeks. Every day you add 1 question. So to get 12 questions, you need almost a week. It's a strategy. Right? And you will tell me the outcome. Ladies and gentlemen, this is the end of session 6. I have a lot to teach you about problem solving, but the Almighty God is saying it is enough for Olenjolai. You can bust my students, they cannot carry what you are teaching them. So, firstly, I thank Almighty God who have taught me the beauty of problem solving about problem solving about conductions of electricity in metallic conductor. Again, I would like to give him all the praise and glory who have taught me in preparations and even at this time when I've been teaching you. But I would like to give thanks to Almighty God who have taught you, who have opened your mind to understand this stuff. It's not me, it's Him who is teaching you, but is living in me who has been teaching you. But maybe I didn't explain some concepts in the level that maybe we expected. So I'm sorry for that. But you can let me know in the comment section. Before I end these sessions, I would like to remind you, into Tanzania Online Advanced Secondary School, in square bracket Olenjolai M, we are not only teaching students, but also we are equipping our students with notes that I prepare myself or even some other teachers of physics, chemistry, mathematics. I appreciate and I acknowledge other physics, chemistry, advanced mathematics teachers who are teaching these subjects in Tanzania. I acknowledge there are so many teachers. Myself, I'm one among them. So we're equipping our students. So it means that we have a library, an online library where you can order books, notes anywhere in Tanzania. So we have so many, we have different books. For example, this is the physics syllabus for advanced secondary school. You can order it or a copy of it. We have questions and answers, books of advanced physics. We have principles of physics or called chapter 1, chapter 2. So you can order. So just to go to the descriptions, we have prepared it. We will prepare a video that explaining the price of each item so that you can see the price anywhere in Tanzania. And in case you want to order, you're welcome to order. So just send a message through this telephone number 07597453 31. Don't bother yourself to make a call. Just send a message. I will call you myself. So keep enjoying the beauty of advanced physics. Another thing that I want to share with you, if you feel from your heart you want to offer our Almighty God your free-willing thanksgiving for this program, you are warmly welcome. Doors are opened, but only to offer thanksgiving, not to offer support. Right? And your free-willing thanksgiving, these are the word of faith. This is the word of faith. You can read this book of Exodus 25 verse 1 to 9. And also you can read the book of Philippians chapter 4 verse 12 to 19 before you offer, in order to know what you should expect. Because whenever you offer your free-willing thanksgiving or offering, God is going to reward you, not Olenjolai. Olenjolai have nothing to reward you, but God have a lot of things to reward you and to reward me. To me, this is my offering. To teach you advanced physics and all of these contents and just publish them into the public, it's my free-willing thanksgiving to God who have given me a gift of teaching. So you may send your free-willing thanksgiving through this telephone number 0759-745331. And your free-willing thanksgiving will be used to pay for the running cost of this program, because we have a vision of recording more than 250 videos of advanced physics. So in total, more than 600 videos. It's very expensive to record one video, but I would like to invite you to join me in order to make sure what is hidden in me is poured out to the present and future generations of advanced secondary students. Again, don't forget to subscribe into our channel and share the contents we are teaching you with other students around the world, around the entire country of Tanzania. But again, don't forget to ask questions and submit your homework in the comment section. I love you so much. This is Olenjolai from United Republic of Tanzania. I love all my advanced students, even if that I don't see you, but God see you, and even God see me, and even yourself you see me. The issue is whether I see you, you enjoy the beauty of advanced physics, you enjoy the beauty of advanced chemistry, you enjoy the beauty of advanced mathematics, you enjoy the beauty of basic applied mathematics from 5 and from 6. Join me in the next session, that will be session 7, which I will introduce to you a new concept, and then visit all other concepts that you've been teaching online right now. Make sure that you are an active online student, because we are publishing new video at least one in a day. Be blessed until we meet. Thank you.